Good afternoon and welcome to this poster presentation on the effect of offspring population size on NSGA-II, a preliminary study by Max Hort, which is me, and Federica Sarro, both from the Department of Computer Science at University College London and the Solar Research Group. The motivation behind this study and analysis is that it has been shown that parameter tuning can be used to improve performance of different search algorithms, including GAs and NSGA-II. However, offspring population size has not been considered during the tuning process. Nonetheless, offspring population size is important because it guides the rate of exploration or the exploration-exploitation trade-off. Which is why we ask ourselves whether population size and offspring population size in NSGA-II should remain coupled, as they are by default equal. We can show this by a smaller example. Given a parent population size in blue, the offspring that are generated in the new generation, which is encapsulated, we can see in the first or the top figure, while offspring population size is equal to parent population size, 2 out of 7 individuals make it to the next generation. If we were now to reduce the offspring population size, therefore have less fitness evaluation, there can still be 2 out of 4 offspring that make it to the next generations. But as you can see, this top individual is missing. Therefore, the offspring is not as performant according to the fitness, but there are still 2 offspring that make it to the next generation. To further investigate this, we perform experiments. In particular, we investigate an NSGA with a population size of 100, 250 generations, and crossover mutation rates, as you can see in the explanation. We measure 4 different matrices on 6 test problems by Zetzler et al. And we compare 3 different strategies with the default configuration. In particular, we keep a fixed amount of fitness evaluations. And by, for example, reducing the offspring population size to 50, we can increase the number of generations to 500. If we increase offspring size to 150, number of generations is reduced, and if we increase it to 200, there are only 125 generations left. We then validate our results with statistical tests, in particular the Wilkinson test. Each test problem is optimized 50 times with each of the 3 strategies and the default. Therefore, we have 24 comparisons for each strategy and the default. Can now move on to the results. At first, we look into the claim we made at the beginning that by having less offspring, the ratio of offspring that can make it to the next generation can still be high. And we can see that a small offspring population size leads to a higher ratio of offspring that make it to the next generation, meaning that if I have 50 offspring and 10 of those make it to the next generation, that if I then increase offspring population size to 100, less than 20 make it to the next generation. Lastly, we can compare the strategies to the default, and we see that only a reduction in offspring size to 50, while increasing number of generations to 500, is able to perform better than the default. In particular, it is comparable or better in 22 out of 24 cases. In conclusion, we want to show that offspring population size is an important parameter to tune, and if you already apply tuning, you might as well include offspring population size in this procedure. Thank you for listening.